All right, guys. It is Marcus here with Realms Gaming for the technical third video in my C++ Masterclass. I hope you guys are enjoying this. I'm taking about a week to do every PowerPoint and every little lecture. Like I said, this first section is going to be I'm trying to keep it 15 to 20 minutes. So, even though this content realistically could be done in half hour, I'm taking my time on it to make sure you guys get, the best out of this. So let's go ahead and start with the section 1.2, which is going to be the language of computers. And the first thing, let me go ahead and just turn off the webcam so you guys can see the full slide. First portion of this is going to be theory and practical applications, programs, and bits. So let's quickly, guys, go over the what is software. So software programs control the computer, such as the OS operating system. The operating system handles the activity of the computer and provides services such as memory management, input-output activities, and storage management. Has special programs that organizes secondary storage. And I do want to kind of touch on this outside of PowerPoint. So as you guys can see, I am on Windows. You can also install... you guys can also install the Linux, which is Ubuntu. And the UI UX on that is going to look slightly different. As you guys can see, I should have just installed it on the computer before I did this, but I was not thinking. It kind of looks like Mac, just a little bit. And a fun fact about Apple is that Apple is actually based off of a Linux kernel. And so, some very common operating system guys are going to be Windows 10 and 11, Mac OS, Linux, and Android. And application programs or apps perform a specific task like word processors, spreadsheets, and games. The operating system runs these programs. So whenever you are technically coding something, especially for this class, we're going to be focused kind of more on apps, not necessarily system programs. Let's go ahead and talk then about the language of a computer and kind of how it works. So there are two types of signals in a computer, analog and digital. The analog signal is going to be continuously varying waveforms, usually representing sound. I am a DJ, so if you guys ever see, like in DJ software, the waveform, that is going to be a digital representation of the analog signal. If you guys want to check that out, download Serato DJ. It's free. Load an MP3 on the deck, and you guys will see what I'm talking about. Digital signals represent information with zeros and ones, with 0 being low voltage and 1 being high voltage. Machine language is a sequence of 0 and 1s. A binary digit or bit is either a 0 or a 1, and then a binary code or number is a sequence of zeros and ones. Bits, bytes, and more. So in the previous video, I told you guys not to really worry about megabytes or gigabytes. We're going to get into that here a little bit. So a bit is just a binary digit of either a 0 or a 1. That's it. A byte is a sequence of 8 bits. I'm going to get into that here in a second. And then 2 to the 10 or 1024 bytes equals 1 kilobyte. And that's going to lead us into this. I purposely did not put the bits and bytes for a peta, exa, or zettabyte, just because at the consumer level, you guys aren't really going to see that. But we go from a byte, which is 8 bits, to a kilobyte, which is 1024 bytes, to a megabyte, which is 1,048,576 bytes. Sorry, math is hard right now. And then as you guys can see, a gigabyte and a terabyte. For reference, most gaming computers, so this computer I'm on now that does everything, I have about 10 terabytes of storage. Most of your work computers are going to only have up to potentially 525 gigabyte, maybe a terabyte. So feel free to kind of pause and do the math on this slide, guys. You can kind of see that we're dealing instead of a decimal, which is base 10, we are dealing in binary, which is base 2. Now we're going to go into the theory and practical applications of binary. When I first started my comp sci program, I did not understand this at first. The way they teach it was not easy. I kind of broke it down in the way that I do it, and you'll still get the same way. So in binary numbering, binary is base 2 versus decimal is base 10, and computers store information in sequence of 8 bits. So whenever you guys are seeing anything on the computer, it's going to be this, this base. So just as an example, let's say we had the number 12. It would be a 1 here and a 1 here because it's an on, 0, 0, 0, 0, 0, 0. So whenever you guys do math, let's say you're just adding 12 plus 1 in the computer, what the computer sees for 12 is this. And now I'm going to kind of go over how to convert. This is kind of getting your brain to kind of wrap around how computers work. So convert 18 decimal to binary. And so 16 goes into 18 once. So we're going to put a 1, which means it is high voltage or on. And then 18 minus 16 is 2. Again, put a 1 there to represent 2, high voltage on. And then that is it. The rest, we're going to put zeros to represent low voltage off on all other bits. So for the 128 slot, 64 slot, 32, 8, 4, and 1 slot, those are going to be zeros. And so 18 decimal is 0, 0, 0, 1, 0, 0, 1, 0 in binary. Let's go ahead and do a higher number now. Let's convert 175 to binary. Guys, go ahead and pause the video. Try to figure this out yourself. And I will see you back in a minute. All right, so you pause the video. Let's go ahead and see how we can do this. So usually in college, they taught us to like divide by 2 and do all this weird stuff. I don't like doing it this way. This is the way that I do it. You get the same answer. So 175 minus 128, because that is the largest. This is the largest. Let me go ahead and get in green. This is the largest number we can subtract out of this number here. So we're going to go ahead and put a 1 there. That leaves us with 47 left. So what is the next highest number that we can subtract from 47? If we do 47 minus 64, it's a negative number, which we don't want. So 47 minus 32 is the highest one we can do, which leaves us with 15. So we put a 1 there. Same thing here. Again, we can't do 15 minus 16. That's a negative 1. So we do 15 minus 8, which equals 7. So there's a 1. And then we pretty much continue this process until, 1 minus 1. And I forgot to put that here. 1 minus 1 equals 0, which means we are done. So in binary, 175 is 1, 0, 1, 0, 1, 1, 1, 1. This again, guys, go ahead and pause the video. I threw a curveball in here, actually. So go ahead and pause the video. Let's get some more practice in. Convert 256, 129, 98, 64, and 17 to binary. Go ahead and pause the video. When you guys are done, go ahead and unpause. All right, let's see what you guys got for this. So again, if you guys need this template, here is the template again. Feel free to screenshot this if you need it. And here is the binary. And you're probably like on this one right here. Where's my cursor? This one right here. You guys are probably like, whoa, this technically has 9. So 256, the next, so, we went from, multiples of 2. So 128, double that is 256. So in binary, you are going to have a 9th place. 129, as you guys can see again, right? 128 is a place that you can have. So it's just going to be 1, all zeros, and then 1 again. There's 98, 64. Again, there's a 64 spot. And then 17. And then I also put the note down here, 256 is the next digit after 128. Therefore, in binary, it is 9 digits. Let's go ahead and talk about why we had to know the binary. Let's go ahead and talk about the theory and practical applications of ASCII. Well, that stands for the American Standard Code for Information Exchange. It is 7 bits. So we're saying, hey, binary is 8-bit. So when you guys are doing American Standard Code for Information Exchange, you want to make sure that you convert it to an 8-bit. So that usually just means putting a 0 at the front end. It is 128 characters labeled 0 to 127. I did want to touch on why we start with 0. So when you guys have a computer, the first position, let's just say that we have an array, which we'll get into later, right? The computer is always going to start at 0. Why? Because of binary. So let's say, these are just random digits, right? Let's just say these are variables in a program. Again, I am just writing, gibberish right now. But when you do an array, this is going to be the location. This is going to be the data. You are always going to start in a computer with 0. So technically location 1 in a computer is always going to be 0. That took me, let me switch to live cam. That took me a very hot minute, guys, to try to understand. My autistic brain was like, whoa, how does that work? I'll actually open Unreal Engine at the end of this lecture and show you guys kind of how it works in an array in a game development program, because I've had to do that for my racing program. But that is how, and then that might also help you guys click a little bit, but this is how you guys do it when we are talking about locations and lists and arrays. So for instance, the character A, this is uppercase A, has the American Standard Code for Information Exchange as a 66, which means the letter A, when you type it in the computer sees it as this binary digit. Character 3 on your keyboard, right? You'd be like, oh, why isn't it just 3? Well, that's not how it works. In the American Standard Code for Information Exchange, the number 3 is 51, which the computer sees that in binary. So this is kind of a little confusing. Just make sure you guys are aware of this. I'm not going to do any conversions on this. There are websites you guys can do conversions, or you can try to figure it out yourself. And that is going to be it for this section. Again, I wanted to keep things short. And as a little bonus, let me go ahead and open Unreal Engine and show you guys for this racing remake I'm doing of LEGO Racers kind of how, that location 0 shows, even though it is technically position 1, the computer sees it as 0. And hopefully this might help it as like a visual representation of like an actual in-use program. Will hopefully help you guys see what I am talking about. Let's let Unreal load for a second. All right, so I'm going to go ahead and use the checkpoints. So if you guys look on the track, you guys can see these checkpoints. So each one of these checkpoints is actually stored in a actor that deals with arrays. And now I have to remember, right here where I put it. So right here, the BP checkpoint manager. If I go here to details, guys. Oh, am I going to have to, here, checkpoints. So it says 6 array elements right here, guys. If you guys can see that, I know I can't really zoom in. But index 0, which is technically checkpoint 1, which is this checkpoint here, technically it is index 0. Second one, index 1. Index 2 refers to checkpoint 3. And you guys can see I have them labeled here as 1, 2, 3, 4, 5, 6. So I just want you guys to kind of get used to that, especially with computer programming. And I feel like maybe showing you guys that in Unreal might have helped a little bit. I hope it did. This video is going to be shorter, 15 minutes. I hope you guys are enjoying this series so far. I will have more documentation, kind of flowcharts on how to build the computer. I'm still working on some handouts that you guys can download off of Google Drive. But thank you guys for watching, and I will catch you guys next time.